Oh, Malachi, thanks for coming in today. I do really appreciate it. When I looked at your file, it looks like we have to still do the Module 2 exam. And I just wanted to make sure that you felt confident when you're doing this kind of stuff. So we've got a Module 2 review. And I'm going to try it out on you first, and then perhaps we can add it to other students as well. Maybe you can add any kind of comments at the end. Okay, so
Okay.
what we're gonna do with module 2 is we're gonna be talking about inequalities, and we'll be talking about absolute values. So here's my little pun on my absolute values. And remember, with inequalities, we've got greater than or equal to, less than, or less than or equal to.
Yes.
Okay. Okay, so this is basically going to be a review, Malachi. And the first kind of things we were working with are one variable equations. When I'm looking at the 2/3 x plus 1 equals 5, this 2/3 is a fraction. Do you remember how to solve for 2/3 x plus 1 equals 5? I'll rewrite it for you. What do you think? How am I going to solve this one?
First you would subtract 1 from both sides.
Okay. All right. And what am I going to be left with on the right-hand side?
4.
Okay, so x is now attached with a fraction. So how would I move that fraction?
You would multiply it
By what?
to 3 over 2.
Oh, you're great. Good. So we're going to multiply both sides by 3 over 2. All right, so now x is isolated on the left, but we have 4 times 3 halves. What do you think?
You would put the 4 over 1.
Okay. Can I cancel anything out?
No.
Let's see. Can I cancel anything out?
The 4 and 2.
And what would I do?
The 4 would become a 2. And the 2 would be, it's 1.
There you go. And then my final answer, multiplying across, x would equal?
It would equal 6.
You got it. You got it. Now, Malachi, if you get an answer and you're not sure if it's the correct answer, okay, you can take this and you can put it right back in to the x at the top here. Okay, and you can find out 2/3 times 6, find out what that is, plus 1, and see if it equals 5. So you can always check. Okay, you can always work backwards. You did great with that problem. You did a really good job. Boy, you've come a long way. Let me tell you something. You're really going after these now. Okay, so let's take a look at this other one. I'm going to rewrite it so it's easier to see. When I type it, it's hard. So here, we're going to put it like this, and I'm going to put it over 3 equals 6. And now I'm looking here. I want to solve for x, but the x is attached to a 2. It's also attached to a 4, and they're also stuck in these parentheses, and we've got a division line with a 3. So we have a lot of things to peel away from the x in this case. I would love to get rid of my addition subtraction first, but I can't because it's stuck in these parentheses. So what would you want to do first? What do you think?
You would multiply the 3.
You got it.
Or
yeah, because look, if we multiply both sides by 3, the denominator is gone now. And now I have 2x plus 4 over here. And what is on the right-hand side?
18.
18. Now, here's something really cool, Malachi. We talk about parentheses. If you look at the parentheses of 2x plus 4, is there anything in front of those parentheses?
No.
Nope. So you know what? If there's nothing in front of the parentheses, I don't need them anymore. The parentheses, if there's a number in front, like a 2, then I would distribute. There's nothing to distribute. So these parentheses can go away.
Okay.
I don't need them anymore. So now I have 2x plus 4 equals 18. Which one would you like to get rid of first, the 2 or the 4?
The 4.
Very good. How would I move that?
Subtraction.
Good. Awesome. Okay, so on the left-hand side, we have 2x. And on the right-hand side, 18 minus 4.
14.
Yep. How am I going to solve for x, Malachi?
Divide 2 on both sides.
Uh-huh. And what is x?
Then x equals 7.
Awesome. Awesome. Okay, so these are your one variable equations, and you rocked it. You did a good job with this. Do you have any questions with one variable equations?
No.
Okay, well, these are high level ones, because if you take a look at this one here, a lot of kids are going to look, especially on this one. This 3 on the denominator is going to mess people up. And so you were very, very quick to say, hey, I need to get rid of the 3, and you multiplied both out. That was a great move right there. So good job. The other thing that a lot of kids mess up on and get nervous about is fractions right here and doing the reciprocal. And you had no problem with that. So very, very good. All right, let's try another slide.
Okay.
Okay, so then another section in Module 2 is translating word problems into equations. Find 3 consecutive integers whose sum is 78. Now, the thing is, when I'm doing that, I have to figure out what the question is even asking. Find 3 consecutive integers. What does that mean, 3 consecutive integers?
It means, like, 3 numbers that are increasing by 1. And the sum of those 3 numbers are 78.
Very good. So let me ask you, let's call the first one x. If my first number is x, what's my second number? Let me put 3 consecutive numbers over here, 10, 11, and 12. If my first one is x, okay? All right, well, how do I get from 10 to 11? What do I add?
Add 1.
So this one would be x plus 1. Okay. Now, how do I get from 10 to 12?
Add 1. Oh, add 2.
Very good. All right, so you tell me now. I'm going to make this disappear. You tell me 3 consecutive numbers. How would I write it? We have the first one is x. The next one would be?
X plus 1.
Mm-hmm.
And then x plus 2.
Very good. Okay. They're saying the sum of these, the sum. What does sum mean?
It means the answer of an addition problem.
Very good. So let's go ahead. It says find 3 consecutive integers whose sum is 78. So if we add these up, they should equal 78.
Okay.
All right, so let's just write it over here. X plus 1 plus x plus 2 equals 78. Okay. Can you help me simplify this? What would we do first here?
You would x plus 1 plus x plus 2.
Okay, we've got that part now, but now we've got this big string of numbers on the left-hand side, and I need to be able to solve for x, but I've got x, 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 and I have a 1 and a 2. They're all over the place, and I need to make things a little bit more compact. What can I do with x plus x? What is x plus x?
2x.
Yep, and how about another x?
3x.
There you go. Very good. So this is 3x. Okay, how about my 1 and my 2?
3.
Yep, so 3x plus 3 equals 78. Now you're down to a regular old algebra problem. How would I solve this one?
You would subtract 3 on both sides.
Okay. And on the left I have 3x, and on the right I have 78 minus 3.
75.
Yep. All right, now I've got the 3 attached. How would I move that 3 to the other side?
Divide it on both sides. And x equals 25.
Very good. So Malachi, let's look at this again. It says find 3 consecutive integers whose sum is 78. If you were going over to your test and this kind of question came up, all right, what would you do to start with? How would you go about figuring this out?
I would do 3x plus 3 equals whatever the number is.
Starting here, yeah. What if I said, and I'm going to just change this just a little, what if we said it was find 3 consecutive even integers? Would it still be x, x plus 1, and x plus 2?
No.
No. If it was 3 consecutive even numbers, that's saying like 2, 4, 6. The first one would be x. What would the next one be?
It would be plus 2.
Yeah. And then the third one would be?
Plus 4.
Yeah. Okay, so even odds are x, x plus 2, and x plus 4. And just consecutive ones are x, x plus 1, and x plus 2. Very, very good, Malachi. Do you have any questions with this problem?
No.
All right, let's try another. Absolute value. Can you tell me in your own words what is an absolute value?
An absolute value is
Take a look at the board. What do you think are the solutions first?
the solutions would be -2 and 2.
All right. Remember, when you get an absolute value, okay, and you've got the -2 in here, you're going to make this positive, and this is going to be 2. So absolute value is always positive. Okay, so both of these are going to be 2. Let's talk about this a little bit more.
Okay.
Okay, absolute value. Can you see the screen? It's defined as a number's distance from 0 on a number line. Okay, so the idea of absolute value is how far away are you from the number? Okay, so for instance, if I was to say, I'm going to add a screen really quick here. Just really quick. Okay, so if I was to say something costs $10, I think it's $10 plus or minus $2. If I was to tell you that, dinner tonight, it's $10 plus or minus $2. Then you're thinking, oh, okay, well, it could be as much as $12, but it could be as low as $8. So what is the distance from 8 to 10? How many dollars difference
2.
is this here?
2.
2. And how many dollars difference is it here?
2.
2. So it's still, no matter what, if it's less than the 10 or greater than the 10, it's still $2 away from 10. And that's what absolute value means. It could be less than it. It could be less than $10. It could be greater than $10, but it's still just $2 away.
Okay.
And that's why the absolute value is positive. In this case, even though 8 is less than 10, it's still $2 away.
Okay.
So that's what absolute value is. Okay?
Okay.
All right, let's try taking a look. Let's calculate some absolute values. So you tell me, can you use your pen now, or would you rather me write them down?
I think I can use it.
Okay. Let's see if you can do the -8. What is the absolute value of -8? Yep, very good. All right, how about the absolute value of 8? Awesome. Okay, so now we're going to see what we can do with absolute value of 3 minus 1. Now you actually have to calculate.
Okay. Think.
What is 3 minus 2?
1.
And what's the absolute value of 1?
1.
You got it. Awesome. Okay, let's come to the next one. The absolute value of 2 times, 2 times the absolute value of -3 plus 2. What is -3 plus 2?
-3 plus 2 is -1.
And what's the absolute value of -1?
1.
And what is 1 times 2?
2.
There you go. Awesome. All right, let's take absolute values a little further. All right, now to get rid of these absolute value bars when we're solving, if you've got an x in there, we have to break it into 2 equations. Okay, do you remember that?
Okay. Yes.
Okay, so if I have the x plus 3 equals 10, what are the 2 equations that I would have?
X plus 3 equals 10, and x plus 3 equals -10.
Very good. All right, so let's go to the first one. How would I solve for x plus 3 equals 10?
You would subtract 3 on both sides, and you get x equals 7.
Good. And how about the right equation?
You would subtract 3 on both sides, and you would get -13.
Very good. And there's my solutions. X equals 7 and x equals -13. Awesome. Let's try the other one, the one on the right side. All right, we've got x minus 2 with the absolute value bars plus 4 equals 10. This one to solve, taking a look at the first one, we had x plus 3 equals 10, and then we just divided it into 2 equations. I can't put this one into 2 equations until I move the 4. So how would I move that 4?
I would subtract 4 on both sides.
Yep. And now I have x minus 2 with absolute values equals
6.
Good. All right, what are my 2 equations?
X minus 2 equals 6, and x minus 2 equals -6.
Okay, let's go back to the first one. How would I solve that one?
Add 2 to both sides.
Okay, and we get x equals 6 plus 2.
8.
Okay, and then how about the second equation?
Add 2 to both sides, and then x equals -4.
Very good. Awesome. Do you feel comfortable with those, Malachi?
Yes.
Good. You did great.
Thanks.
Oh, we have more absolute values. Boy, these things just keep coming, don't they? Okay,
Yeah.
so now, again, we can't break this absolute value into two equations until first we get rid of the -4 and then we get rid of the 2. Then we can set up our two equations.
Okay.
All right, what do you think? What do you want to do first on here?
Add 4 to both sides.
All right, so on the left, now I'm left with 2x minus 2 equals, what is 20 plus 4?
24.
Okay, now what do you want to do?
I want to divide 2 on both sides.
So now we have absolute value of x minus 2. Oops, that's a straight line. Equals, what is 24 minus 2? 24 divided by 2.
12.
Yep. Okay. All right, we're ready. What are my two equations?
X minus 2 equals 12, and x minus 2 equals -12.
Good. Okay, what am I going to do to solve here?
Add 2. And x equals 14.
Yep. And then on the other side?
Add 2 to both sides. Then you get x equals -10.
Very good, Malachi. Awesome. All right, now we've got one more equation. I think this is it for absolute value.
Okay.
Let me pick a different color. Okay, on this one here, it's the same kind of deal. We've got the 6 that's attached to the bars and the 3 that's attached to the bars. So what do you want to get rid of first?
The 6.
Okay, so I'm going to subtract 6 on both sides. So now we have 3x plus 3 equals 3 minus 6. What is that?
-3.
Yep. All right, now what do you want to do to both sides?
Divide by 3.
Okay, now I've got my absolute value of x plus 3. And what does it equal?
-1.
Okay, we have a problem. What do you see?
It's a negative, so we can't go on.
Exactly. This is a negative, and absolute values cannot equal negative, so you cannot go on. The reason I allowed you to come all the way down to this point to find the negative, and I didn't stop you here, was because I have seen questions where instead of a 3, say this is a positive 3 or something, and then there's a negative here. You want to make sure you get rid of the number in front first and divide it off to see what the final product looks like of this. And so you want to break everything away and get these looking all by themselves and then see if it's a negative number. Don't do it prior to that, just in case they put a little trick in there. And they do.
Okay.
And the test actually does put a trick in there. Okay. Now we're on to inequalities. All right. And we've got greater than and less than or equal to. We have equal to. When I'm graphing on a number line, okay, how do I show greater than rather than greater than or equal to?
A open circle.
Yeah. So what is the difference between open circle and closed circle?
Open circle is greater than or equal to and less than or equal to.
You've got the right idea. Let's try it. Let's look at the first problem, and then we'll go through and see it, and you'll see it a bit clearer. We have x plus 2 is greater than 5. How do I want to make x by itself? What do you want to do with that 2?
Subtract 2.
Yep. When I do that, I get x is greater than 5 minus 2.
3.
Yeah. Okay, let's go ahead and graph it. We got to find 3. Okay, here it is. 3 is over here. You say it's greater than. That means it's going to be an open circle. Now, which side do I graph? To the right or to the left?
To the left.
Okay, give me some numbers that are greater than 3. You tell me, what number is greater than 3?
4, 5,
4,
6.
5. Where are they located? Are they
Towards the
located
right.
over here, or are they located over here?
The right.
They're located on the right. There you go. So that's where I want to shade. I want to shade on the right. Okay, and the open circle means I cannot, it doesn't include 3, it's greater than 3. That make sense?
Yes.
Okay, let's try the next one. 2x is less than or equal to 10. How am I going to solve for x?
You would divide by 2 on both sides.
Yep. Okay, and x is less than or equal to?
5.
Yep. Okay, all right, so let's find 5. Now, does it include 5? X is less than or equal to. Does it include it?
Yes.
Okay, so let's put a dot. What are numbers that are less than 5?
4, 3, 2, 1.
This way. Yeah, so my graph is going to go this way. Are you comfortable with that, Malachi?
Yes.
Great. Okay. Here we go. Disjunction or. Okay. X is going to be this or this. Hi, Max. We're almost done here. All right, Malachi. When we do or, it could be this group. X can be all this stuff over here, or it can be all this stuff on the right. It can be the left stuff or the right stuff. So we can include both on the number line. Let's do the first one. 6 plus x is less than 4. Okay, how would I solve for x here?
I would subtract 6 on both sides.
So now x is less than?
X is less than negative 2.
Or, now we have negative 5p is less than or equal to negative 30. What am I going to divide by on both sides?
You'll negative 5p.
Just negative 5.
Okay.
And that means p. Now, what happens when we divide by a negative to our inequality sign?
The sign changes.
It sure does. So it's greater than or equal to. And this is negative 30 times negative divided by negative 5, which would be?
6.
6. Very good. Okay, let's find our points. 6 is greater than or equal to. So is it open or closed?
Oh, close.
And it's greater than. Which way do you want to shade?
To the right.
Yep. Okay. And now x is less than 2. Is that open or closed?
Open.
And which way do you want to shade?
To the left.
There you go. So it can be either or of these graphs. When you have or, it can be this one or this one. If this was and, if this word was and,
Okay.
if it was and this one, it would be no solution because there's nothing in common between these two. Or means go ahead, take either one, and means take what's in common for both graphs. And in this case, with both graphs, there's nothing in common. So and, there's no solution, or would be this solution. Does that sound okay?
Okay.
Awesome.
Yes.
All right, conjunction and this is, we're coming to the end of this. All right, and means both of them have to satisfy the solution. Okay, so here we go. We have, if I get rid of these absolute values, what are my two equations?
X is less than 2 and x is less than negative 2.
Yeah, forgot to tell you this. Okay, when you get rid of this, okay, with inequalities, it's definitely negative 2, but then you take the sign and you switch it.
Okay.
Greater than negative 2. Okay, so when you're doing this with inequalities, it's just like equations where you have 2 and negative 2, but you have to switch the sign on the second equation. So make sure you remember that. I know when we're doing equations, you only change the sign when you divide by a negative, but with inequalities, you do change that second time. Okay, so x is less than 2. This is a lousy number line. Oh my gosh. Here it is. Here's 2. Okay, which way do I want to shade?
You want to shade to the left.
Okay, I'm going to shade to the left. Okay, then we have x is greater than negative 2. I think negative 2 is here. Okay, it's open circle. Which way are we going to shade?
To the right.
To the right. Okay, if both of these things have to happen, where do you think my graph is going to be, my solution is going to be?
It will be in the middle of the circles.
Yeah, it sure will. Right in here. Very good. So conjunction is got to include both of them. Very good, Matt.
Thanks.
All right, let's see. I'm going to go ahead and give you just one last thing because I know I see your brother here. Literal equations. F equals ma. Solve for a. Okay, so what they're going to do with literal equations is they give you a bunch of letters, and you have to rearrange and solve for another letter. And most of the time, all the letters are attached by multiplication. So in this case, F equals ma, and I need to solve for a. I've got an m attached to it. How am I going to move the m to the other side?
Divide it.
Yep. So what does a equal?
A equals F over M.
You got it. Okay, and let's try this last one. P equals IRT. How would you solve for t?
You would divide it by IR.
Okay, so t now equals what?
P over IR.
Very good. So that's what literal equations are, just moving things around. Do you feel comfortable with literal equations?
Yes.
Good. That's it. Okay, same thing here. Solving for m. Before, I know we're running out of time, so very quickly, if I was to solve for m, without solving, tell me how I would solve it. What would I do with the b?
You would subtract it.
And then what would be my next move?
You would divide X.
You got it. Very good.
Both sides.
So you would subtract b, and then you would divide everything by x. Very good. If I was solving for z, over here, x equals yz over 6. What would I do for this one?
Okay. You would
You're saying it.
multiply 6 on both sides. And then
so you have 6x equals yz.
Divide y on both sides.
You got it. That's exactly what you do. Malachi, do you have any questions at all?
No.
All right. Well, I see your brother in here for another help session, so you did great today. So I want you to go in there and take your test. It's Module 2. The password is CAT, C-A-T.
Okay.
All right. You have a great morning, Malachi. Thanks for working with me.
Thank you.
Bye.
Bye.